All right, 9.5b continued. For series that have positive and negative terms but are not alternating, for instance, negative, negative, positive, positive, negative, negative, positive, positive, the following test can show whether the original series converge or diverge. The converse of the absolute convergence theorem is not true. For instance, the alternating harmonic series, right, this divergent harmonic series, however, in the presence of an alternator, converges by the alternating series test. We saw that before. However, the absolute value of this series, which is the normal harmonic series, which is what we learned, 1 over n, is divergent by the p-series test. If the absolute value of the series is divergent and the original series is convergent, we call this conditionally convergent. Okay. So definitions of absolute and conditional convergence. So absolute convergence is where if a series converges when all the terms are made positive, then the original series will converge. Okay. Conditional convergence is where a series need the presence of an alternator in order for the series to converge, meaning that without the alternator, the series will diverge. And the perfect instance of this, or the easiest instance of conditional convergence, would be the harmonic series. Okay. The series converges on the condition that it needs the negative values from the alternator in order to make it convergent. Okay. So if that's the case, then it's conditionally convergent. It is conditional on the fact that there needs to be a change of signs. So let's look at example 6 here. Negative 1 to the n times n plus 1 over 2 over 3 to the n. There's an alternator for negative 1 to the n. But as is, the series will converge by alternating series test, because this a sub n, this 1 over 3 to the n, is going to be 0. So regardless of whether this alternator is here or not, the 1 over 3 to the n will converge to 0. And if it converges to 0, we can say that that the series will converge absolutely. Okay, simply because this is a geometric series where the ratio is less than 1. Okay, example 7, the alternator is present, and we can see that this is limits 1 over n to the 2/3. Now 1 over n to the 2/3, the limit as n approaches infinity of this is equal to 0. Okay. However, this will diverge by the p-series test, because if we just look at this without the presence of the alternator, the 1 over n to the 2/3, this is p-series, and that p-value is equal to 2/3, which is less than 1. So even though this initial series is convergent by the alternating series test, it will be divergent without the alternator, because without the alternator is simply a p-series that is not greater than 1 but less than 1. So this series converges conditionally.